Hey everyone, welcome back. So another quick video in this series where I'm using R to conduct data science tasks and do data analysis. So I'm in RStudio again, and what I'm going to do in this particular video is demonstrate how to create violin plots using ggplot. So in a previous video we created some box plots to look at the distribution of scores on a numeric variable where you can split them by, say, groups on a categorical variable. Violin plots are another useful way to present that type of data. So we've got scores on a numeric variable across different groups on a categorical variable. So violin plots and box plots, they share some similarities. But a violin plot uses like a smooth density plot instead of a rectangular box, and this makes it much easier to see the actual distribution of scores where there's more, where they're kind of clustered and things like that for the groups on the numeric variable of interest. So to do this, I'm gonna, as I've done in pretty much most of the videos that I've recorded for this series, I'm gonna load the tidyverse package, that umbrella package that's got a lot of data wrangling and data visualization packages contained within it. So I've done that. It's executing at the moment whilst I speak. You can see there it is. It's kind of come up with. It's told us what it's loading: dplyr, tidyr, tibble, ggplot2, and it's told us what the conflicts are. I've mentioned these a few times now. This is where we've got kind of function names that are the same in more than one package. So we need to specify exactly which one we want when we use that particular package. But what I'm going to do is I'm going to use a data set that is kind of built into R. It's the iris data set. I think if I run data and iris, I think it's the referred to as the Anderson iris data set after the name of the person who collected it. So it's measurements of like petal length, petal width, sepal length, sepal width for 3 different species of iris plant. So I've used it as it's quite a commonly used data set for in machine learning, for trying to use algorithms to classify data based on whether it's one species or the other. And I'm going to use it as an example. I've used it in a number of other videos for like where I've demonstrated how to do these types of things in Python, but I thought I'd use it in R as well. So I've just run that. I've run the command data, and then in parentheses in double quotes I've specified iris, that's the data, and it's loaded it here. You can see in the global environment it's built-in data set. We've got 150 observations of 5 variables, and then I ran the glimpse command. That's kind of useful if you remember from previous videos. It shows us what each of the variables is and what the name of it is, and it tells us the type of the data type of it. So sepal length, sepal width, petal length, petal width. If you look in this bottom in the console at the bottom, they are all shown as dBl, and that's double precision or numeric decimal point numeric variables essentially, or what are often referred to in other programming languages as floating point numbers. Species, on the other hand, is shown as FCT, and that stands for factor. So it's already a factor, a categorical variable. That's good in this sense because we want it to be, because that's the categorical variable we're going to look to plot. But if it hadn't been, if we'd imported this data, say, and species was shown as a string variable and not as a factor, we would have had to convert it to a factor. But saving me some work here in the sense that it's already the correct kind of data type for a categorical variable. So I'm going to start by creating a simple violin plot, and to do this I'm not going to create a new object or anything like that. I'm just making the ggplot call, and then parentheses, and passing a series of arguments, and those are the data, the mapping or the aesthetics, what things we want to plot on what axes, and then outside of the kind of the initial ggplot call, I'm telling you what geometry. So you'll know those are the 3 things you need to specify when you're using ggplot: the data you're using, the aesthetics you want, so the axes you want, and then how you want the data points to appear. So in this case, I've gone back to kind of the old style and I've made it explicit and saying data equals iris, so we're going to use the iris data set. Mapping equals AES, that stands for aesthetics, and then in parentheses I'm saying which variables to put on the axes, which variable to put on the y-axis. So we're going to just use species on the x-axis and sepal length. And notice how I spell it, sepal.length. That is because that is how, if you look in the console below here, that's exactly how it appears in the data set. And then outside those parentheses, I've put a plus sign, and then I've said geom. The geometry we want is geom_violin. So this is going to give us a real basic violin plot. So let's run that and see what they look like. And that's going to, once that's run, it's going to pop up here in our little plots window. So you can see we've got three species: Iris setosa, Iris versicolor, and Iris virginica. And sepal length is our numeric variable. So the way you can look at these, if you kind of look at my screen here, they kind of, if you split these down the middle, let me not do that. If you split these down the middle, what you're seeing on either side kind of reflected across the center line here is a density plot, essentially, or what we could refer to as a kernel density estimator. It's some sort of continuous plot of the distribution of scores. So what we're seeing here is the distribution of sepal length for setosa. So a lot of them are around 5, fewer as it's more small and higher values. And like same here, if we kind of just, if we consider this to be split down the middle, and we just focus on one side, then we can see here the distribution of scores on versicolor, kind of like fewer at these lower values around 5, quite a lot kind of around 6, and then it tapers off up towards 7. Likewise for the other. Obviously, you can see the difference in length between these three species. Virginica obviously has much longer sepal than the other two, by the looks of it. Okay, so that is the useful thing about these when we compare them to box plots, where with box plots they just return like this rectangular box for the quantiles, the middle 50% values. That actually hides or masks quite a lot of information about where it gives the impression that that along that 50%, those quantiles, the scores, we don't know how they really are distributed. It looks like they're evenly distributed when they're not, but you can, with a density plot like this, a continuous representation of the data, then it is easier to see how the data is actually shaped. Okay, so the default is to set the shape of the violins to the range of the data, but we can set this to false using the trim argument. So all I'm going to do here below is, on this command, I'm calling exactly the same plot that we just did, but I'm setting trim equal to false. And what's going to happen here is you'll kind of see the I prefer this, to be honest with you. You'll see the kind of you'll see the whole range of the data. So more, you can see sort of beyond the actual values that appear in the data set. To the whole range, essentially. Another interesting thing we can do here to make this a bit more interesting is we can actually overlay a box plot on top, and that's kind of, I think that's a useful way to be able to see where the median is and the quantiles. So we can overlay a box plot on the violin plot, and that gives us an indication of what the quantiles are. So all I've done, you can see in lines 29 and 30 there up to here that I've highlighted, you can see that's exactly the same plot call as the one above, this one we're currently looking at it. But then I've added a plus, and on the next line I've added geom box plot, and I've specified the width because I don't want it to kind of like, I don't want it to be like as big as the violin plots. I just want to use it to get some indication of the kind of the quantiles, essentially. So if I run that command, you can see there we've got the kind of box and the classic box and whiskers, and that it sort of gives us this clear indication of where the median is, where the quantiles are, okay, and the length of the whiskers. Okay, so that's pretty useful, I think. We can obviously do a lot more with these. I'm not going to outline all the possible ways in which we can change the aesthetics and add labels and things like that. But we could add some, if we want to add if we want to add colour to the plot, if we use the colour argument, so I'm just going to correct that. If we use the colour argument, this just outlines the contours of the density. So what I'm doing here is I'm taking the above plot, or the more simple without the box plot included in it. So I'm saying ggplot, iris data, species on the x-axis, sepal length on the y-axis, and then I'm adding this colour argument. I'm saying set the colour equal to species, and then we've got our plus specifying the geometry as violin. So let's run that and we can see what that looks like. So you can see it has given each species its own colour, but it's only given us the kind of symmetry, the outline. In order to kind of change the colours of these, the argument we need to use is the fill argument. Okay, so in order to make this red and this whole area green and this one blue, we need to change, rather than use colour, we can just specify fill. So we could leave colour in if we wanted some sort of different coloured outline, but all I'm doing in this bit of code here, this block of code between lines 40 and 42, is just, rather than including colour equals species, I'm specifying fill equals species. So let's look at that. There we go. That looks nice now, I think. So we've obviously got a key for the different colours, and toes are vertical of Virginica, species, sepal length. But we might also want to add the box plot on top of that. So perhaps this would be kind of the plot we were looking for, without doing any kind of nice tidying up and changing the x and y axis labels or giving it a title or anything like that. We can always change the labels in some way. I'm not going to go into too much depth on that. So yeah, maybe that's our final plot, but we would want to do some extra kind of like setting these labels so they're not spelled like they are on data frame, but they're actually clearly say sepal length, and maybe give it a title and things like that. What I'm going to do just to finish this video off is kind of demonstrate the same thing, this plot above here. I'm going to miss off the box plot, I think, but I'm going to demonstrate the exact same plot, but using the tidyverse pipe operator that we've seen in other videos as well. So this is my kind of preferred way to do it. Is kind of more intuitive, piping the first argument is the input to the next argument. So what I'm doing is, firstly, I'm just specifying the data as iris, and then I'm going to pipe that into the ggplot call. We've specified I've tidied it up and to make it more more compact, less explicit, but more compact. So I've got rid of data equals, because I don't need to. I need to say that because I've specified it as here when I've piped it in, and I've got rid of like the mapping equals and just specified the AES, and X equals just saying species, and ggplot will know which ones these are that we're calling. Okay, so let's run that. You go, and there we go. We get perhaps this is our final plot that we might be looking to create on some data set. And you can then do the various things you want to do, such as changing the labels, adding a title, and then exporting it, saving it as some sort of JPEG or PDF file. Okay, so that is Violin Plots. Key takeaway from this is they're very easy to create once you know how to work with ggplot with your data, your mapping, your aesthetics, your geometries. And they are a very useful way of visualizing what the actual distribution of the data is. Okay, so the next video I'm actually just going to focus on density plots, which are simpler than this, and sort of compare them to histograms. All right, thank you for watching and listening, and I will see you soon.